So let's say I have a number z, okay, which is equal to a plus ib, okay, a plus ib, where a and b are raw numbers. So a and b are what? Raw numbers, okay. And then raw numbers. And then the I is known as what? The iota. Okay, and that's equal to the square root of what? -1. So looking at this number z here, it has what? Two parts. One being just a and then one being what? I multiplying b. So we call this a here the raw part. Okay, and then we call this side the imaginary part. Okay, that's the imaginary part. Okay, so what that happens here is that any number that has a real part and then an imaginary part is known as what? A complex number. Okay, so this number is known as what? A complex number. So an example is I can have 2 plus 3i. Okay, this is a complex number. I can have 4 minus 2i. This is also a complex number. But in a situation whereby you have, let's say, just 3i, okay, we call this a purely imaginary number. Okay, this is purely imaginary. Purely imaginary. Okay, so you can have a number as what? Let's say z to be equal to what? 3i. Okay, this is a purely imaginary number. You can write this as z equals what? 0 plus what? 3i. Okay, same way you can have what? Let's say z equals what? I. Okay, this can also be equal to what? Z equals what? 0 plus what? I. Okay, this is still what? A purely imaginary number. Okay, so when you write complex numbers in this form, let's say z equals what? A plus ib here. We call this what? The standard form or the rectangular form. Or the rectangular form. Okay, so we can write complex numbers in the rectangular form, and then you can write it in the polar form, and then you can also write it in the exponential form. You can also write complex numbers, this z here, okay, as what? A comma what? B. Okay, where A and B may be considered as what? The coordinates of what? Of a plot. Okay, so you can consider A and B to be the coordinates of a plot. So let's look at what that means. So let's say I have a plot here. Okay, this plot is known as the Argand diagram, where the x-axis is named as what? The real axis, and then the y-axis is named as what? The imaginary axis. Okay, so I can plot z here. Okay, this is z here, and I have what? A and B here. This is known as what? The Argand diagram. Okay, the Argand diagram. So we are going to learn how to perform some algebraic operations on what? Complex numbers. So you can perform addition, subtraction, multiplication, and then division on complex numbers. So let's look at how we can perform what? Addition and then subtraction on complex numbers. Then later on we learn about how to perform division and then multiplication on complex numbers. So let's say I have a complex number z1 to be equal to x1 plus what? I y1. Okay, and I have another complex number z2 to be equal to what? x2 plus I y2. Okay, so if I want to add these two complex numbers, what I'll do is that I'll add the real part separately and then add the imaginary part separately. This is because we can't add the real part to the imaginary part. Okay, it's not possible. So to add z1 and then z2, that was z1 plus z2 will be equal to x1 plus I y1, okay, plus x2 plus I y2. Okay, this is what I have now. So this will give me z1 plus z2 to be equal to. I'll write them out of the bracket. Okay, you don't really need the bracket here. So that was x1 plus I y1. Okay, plus x2 plus I y2. Okay, so now we are going to group like terms. Okay, so that we add what? The real part separately and then we add the imaginary part separately. So that was x1 plus x2. Okay, plus iy1 plus iy2. Okay, so this is what I have now. So you can further simplify this. Okay, so this will be equal to what? X1 plus what? X2. Okay, then I'll factor out the I since it is common to both y1 and then y2. So that what? I multiplying y1 plus what? Y2. So this is how to add complex numbers. So let's look at how to perform subtraction of complex numbers. Okay, so to perform subtraction of complex numbers, let's look at how you are going to do it. So that was z1 minus what? Z2. Okay, so this will be equal to x1 plus I y1. Okay, minus what? X2 plus what? I y2. So let's look at how you are going to do this. So this gives me z1 minus what? Z2 equals. So you don't really need this bracket, so I will ignore it. That what? X1 plus what? I y1. Okay, and then for this part also, let's distribute this negative to x2 and then iy2. So let's consider this place to be 1. Okay, there is 1 there, but we don't really make it divisible. So that was minus 1 times what? X2, that was minus x2. And then minus 1 multiply what? Iy2, that was minus iy2. So from here, that was z1 minus what? Z2 to be equal to. We are going to group like terms here. So that was x1 minus what? X2. Okay, plus iy1 minus what? Iy2. This is what you have now. So from here, you can do the subtraction. Okay, so this will give me z1 minus what? Z2 to be equal to what? X1 minus what? X2. Okay, plus we factor out the I since it is common to them. So that's I, that was y1 minus what? Y2. So this is how to perform subtraction of complex numbers. So let's take some examples to help us understand this. So with the first example, I have these two complex numbers, minus 4 plus 7i. And then another complex number, 5 minus what? 10i. Okay, so I have to perform addition and then subtraction on these complex numbers. So I'll consider this to be z1, then I'll consider this to be what? Z2. So to perform addition, that was z1 plus what? Z2. Okay, so this will be equal to minus 4 plus 7i. Okay, plus z2, which is what? 5 minus what? 10i. Okay, so this will give me z1 plus what? Z2 to be equal to what? Let's write these values out of the bracket. So that was minus 4 plus 7i. And then this side also have what? Plus what? 5 minus what? 10i. Okay, so from here I'm going to group like terms. So that gives me z1 plus z2 to be equal to what? We have the real part which is what? Minus 4 plus 5. And then the imaginary part which is what? Plus 7i minus what? 10i. Okay, so this will be equal to z1 plus z2. That will be minus 4 plus 5, that be what? 1. And then 7 minus 10, that be what? Minus 3. So that minus what? 3i. So this will be the answer for this. So now let's perform subtraction on these complex numbers also. So that was z1 minus what? Z2. So this will be equal to what? Minus 4 plus 7i. Okay. Minus 5 minus what? 10. 5 minus what? 10i. Okay. This is what you have now. So now let's continue. So this will give me z1 minus what? Z2 to be equal to minus 4 plus 7i. And then considering this part, you are going to distribute the negative sign here to the values in the bracket. So that what? Minus 5 plus 10i. Okay. So now we can group like that. So that will give me z1 minus what? Z2 to be equal to what? Minus 4 minus 5. And then plus 7i plus what? 10i. Okay, so now let's simplify this. So this will give me z1 minus what? Z2 to be equal to what? Minus 4 minus 5, that will give me minus 9. And then 7i plus 10i, that what? Plus what? 17i. So this will be the answer. Let's try another example. So I have another complex number 2 plus 3i. And then another one has 3 minus what? 4i. So you have these two complex numbers. So you have to perform addition and subtraction over these two complex numbers. So let's look at how we are going to do that. So I'll consider this to be z1. Okay, and then I'll consider this to be what? Z2. Okay, so z1 plus what? Z2 will be equal to what? 2 plus 3i. Okay, plus 3 minus what? 4i. Okay, this is what you have now. So this will give me z1 plus what? Z2 to be equal to 2 plus 3i, and then plus 3 minus what? 4i. So now we are going to group like terms here. Okay, so that gives me z1 plus z2. We are going to group the real parts and then the imaginary parts separately. So that what? Z plus 3, and then plus 3i minus what? 4i. So this will give me z1 plus z2 to be equal to what? 2 plus 3, which will be 5. And then 3i minus 4i, that what? Minus what? 1i. So this will be equal to what? 5 minus what? I. Okay, so now let's perform subtraction of what? These two complex numbers also. So that what? Z1 minus what? Z2. So this will be equal to 2 plus 3i. Okay, minus 3 minus what? 4i. Okay, so now that will give me z1 minus what? Z2 to be equal to 2 plus 3i. So let's distribute this negative sign. So what? That will be like minus 1 times 3, that what? Minus 3. Then minus 1 times minus 4i, that what? Plus what? 4i. So this will be equal to, so I'm going to put the like terms, that was 2 minus 3, and then plus 3i plus what? 4i. So this will give me a value of what? 2 minus 3, that was minus 1. And then 3i plus 4i, that will be what? Plus what? 7i. So this will be the answer. Now let's take another example. So in this example, you can choose to pause the video and then try it. Then afterwards, you check my solution. So I have two complex numbers, which is 4 plus 7i, and then 2 plus 3i. So I'll consider this to be z1, and then I'll consider this to be z2. Okay, so you have to add z1 and then z2. So that'll give me z1 plus what? Z2 to be equal to 4 plus 7i. Okay, plus 2 plus 3i. So now simplifying this, that will be 4 plus 7i plus 2 plus 3i. Okay, so now let's group like terms. So that would be 4 plus 2, then plus 7i plus 3i. Okay, so this will be equal to what? 6 plus 10i. Okay, so now let's perform subtraction on what? These two complex numbers also. So that what? Z1 minus what? Z2. Okay, so this will be equal to 4 plus 7i. Okay, minus 2 plus 3i. Now let's continue. So this will be equal to 4 plus 7i. So now let's distribute this negative to the values in the bracket. So that would minus 1 times what? To that what? Minus 2, and then minus 1 times 3i. That what? Minus what? 3i. So now let's group like terms. So that will be 4 minus 2, then plus 7i minus what? 3i. Okay, so this will be equal to what? 4 minus 2 is 2, and then 7i minus 3i, that what? Plus what? 4i.